This is section 5.5. We're going to talk about multiple angle formulas. Sorry, we're going to do double angle formulas today. Here are three different equations for us. These are all on your formula card. So there is only one formula for sine of a 2u. So if we're doing a double angle, and that formula becomes this: 2 times the sine of u times the cosine of u. That's the only variety we have. What you need to know is that sine of 2u is not 2 sine of u. You can't just take the sine value of a triangle and then times it by 2. That's not the same thing. We're talking about doubling the angle, not doubling the value. Cosine, weirdly, has three versions. This is the first one, this is the second one, and this is the third one. You can't you're not going to attempt to rearrange these to become each other. These are just the three versions of this formula that you could use. So whichever one comes in handy for you. Again, I am going to write that this is not the same as doing 2 cosine of u. You can't just double the value. We are doubling the angle. So one of them is you can do cosine squared minus sine squared. Has to go in that order because of the subtraction. You can do 2 cosine squared minus 1, or you can do 1 minus 2 sine squared u. Last up, you have tangents, always in a fraction, always difficult. I will write again that this is not the same as doing 2 times tan. You can't just slide that 2 up front. But the formula for tan is 2 tan and then over 1 minus tan squared. And we're going to do a couple so you see how all this works. So the first one says I've got the cosine is 5/13, and then the angle is located between 3 pi over 2 and 2 pi. So that is quadrant 4, and they would like me to find all of these. So to put this in quadrant 4, I'm just going to draw myself a quick picture. From the origin, I would go over, and then I would go down. So that's my triangle. Cosine is adjacent over hypotenuse. Doing Pythagorean's theorem real quick, I know that that is negative 12. Negative because we're headed downward. The first one they want me to find is sine of 2u. So sine of theta. So the formula for that is 2 times the sine of theta times the cosine of theta. So 2 times the sine of this triangle is negative 12/13, so opposite over hypotenuse. The cosine of this triangle is 5/13. They gave that to me, plus it's adjacent over hypotenuse. This 2 is really over a 1, and so now we can just do the multiplication across. So 2 times negative 12 times 5 gives me negative 120, and then 13 times 13 is 169. So that's the sine of 2u. Now we're going to do the secant of theta. I keep saying u. Secant of 2 theta. We don't have a formula for secant. We do have a formula for cosine. So if I could just do the cosine value, then all I have to do to find the secant is just flip it over. So I'm going to do cosine first. And you can pick any one of these three to use. Here is my suggestion. The problem gave you the cosine value, so I would pick the formula that just has the cosine value. Let's just say in some weird world, you mess up Pythagorean's theorem and you don't get the 12. If you use either of these formulas, they're also going to use the 12 because of the sine, and this answer is going to be messed up. So I would suggest just using whatever's in the problem. So since they gave me cosine, I'm going to use this second formula, but it does not matter which one you use. So we're going to do 2 times, and then we're supposed to do the cosine of the triangle squared, and the cosine was 5/13. And if you want to grab your calculator, that's totally fine. Just keep it in fraction form since we're doing exact values, so no decimals. So 2 times 5/13 squared minus 1. You would get negative 119 over 169 when you type that in. And then since we wanted to actually find the secant, we're going to flip that. And so our answer will be negative 169 over 119. Last one we're going to do is the tangent. And the tangent formula is this thing right here. So I'm just going to start plugging stuff in. So this says that I'm supposed to do 2 times the tangent value, which would be negative 12 over 5. Then I've got 1 minus that exact same thing, but squared. So up on top, I've got negative 24 over 5. Sorry, I'm trying to move down a little bit to get out of the way of that. Then I've got 1 minus, and when I square this, I would get 144 over 25. This is a little tricky to get into your calculator correctly and not mess it up. So I would suggest just taking it in stages. So if you just leave the 24 over 5 for now, and we just do the bottom, so 1 minus 144 over 25, you're going to get a negative 119 over 25. This might be a little easier to enter in your calculator. Just watch your parentheses. I'm just going to flip the bottom and bring it up. So that'll all cancel. I have two negatives. That'll cancel. Oh, geez. I wrote it. I was looking at the wrong thing. I'm flipping it, so the 25 should be on top, and the 119. Negatives still cancel. 5 goes into that 5 times. So then 5 times 24 is 120, and then the bottom was the 119. You can type that in your calculator. It'll give it to you. You just have to really watch your parentheses and how that gets entered. One more of these. I've got the sine is negative 4/7, and the angle, again, is in the 4th quadrant. So I'm going to put a triangle down there so I can get a look at it. The sine value is opposite over hypotenuse, so this will be negative 4/7. I'll do Pythagorean's theorem, so it'll be negative 4 squared plus whatever this side is equals 7 squared. So I've got 16 x squared and then 49. So bringing that over, I will get x squared equals 33 and then just square root. So this side is the square root of 33. Not nearly as clean or as pretty as what I had up there. First one they want me to find is cosine of 2 theta. So the cosine the cosine formula, you can choose any one of these. In this problem, you got the sine value, so I would use the formula that has the sine. That way, if there is a mistake in your math, like if you don't trust the square root of 33, then let's not use it. So let's just do 1 minus 2 sine squared. And the sine in this triangle is negative 4/7. They gave that to me in the problem. So 1 minus 2 times, and if you square those, you get 16 and 49. Your calculator can do this for you. You can type that in. Just make sure you hit the fraction button. We want exact values, not decimals. Tangent, that formula starts off being 2 times the tangent, and the tangent is going to be negative 4 over square root of 33. Don't get excited about the square roots in the denominator yet. Like, let's see how this is going to play out for a little bit. Don't try fixing them right away. Sometimes they get rid of themselves in the course of the problem. So these two are going to multiply, so I've got negative 8 over square root of 33. And then on the bottom, I've got 1 minus. When you square negative, that'll turn positive. I'll have 16 over 33 because the root will go away. If you needed to, you can use your calculator to do the denominator. The 1 minus 16 over 33. That's going to be 17 over 33. I'm just going to flip the bottom and bring it up. This one, you can't use your calculator because of the square root of 33. Your calculator can't give that back to you or keep it in a fraction form. It can only do it as a decimal. So unfortunately, by hand is the route you're taking. So I've got an 8, a 33, a square root, and a 17. And I know this is weird, but I'm going to write them like this because we know some stuff's going to cancel. We've got this root to deal with, and by multiplying both the top and the bottom by square root of 33 to get rid of it, I'm going to actually end up with some stuff that can cancel. I got to take up a little bit more room here. So when I multiply these two roots, on the top I'm going to have negative 8, I'm going to have 33, and I'm going to have root 33. On the bottom I'm going to have a 17, and these two will make me a 33. So this will cancel. You might not see that or know to divide by that if you multiplied all this first. You just would have a really big fraction that you might need to try and reduce. So negative 8 square root of 33 over 17. The last one I've got is cosecant. Well, I don't have a formula for cosecant, but all I'd have to do is find sine and then flip it. So I'm going to find sine of 2 theta first. And that formula is 2 sine theta cosine theta. So 2 times the sine value. They gave me that in the problem, so negative 4/7. The cosine is square root of 33 over 7. So I'm just going to multiply straight across. So 2 times 4 gives me negative 8, and then square root of 33 over 49. Now that's the sine value, so we have to flip it for cosecant. So our cosecant of 2 theta will be negative 49 over 8 square roots of 33. And we can't leave the 33 in the bottom, so we'll quick fix that. So I've got negative 49 square roots of 33 over 8 times 33. So one more. Negative 49 square roots of 33 all over 264. So the pre-calc that you have really here is being able to set up the triangle and use the formula. And then you've got a bit of algebra just trying to get to the exact value.